Hello everyone and welcome back to Diksha Karnataka YouTube channel, and here I am back as promised in the morning. I promised you that I will be back with all the solutions for the question paper given to you, the mock test number 1 of the KCET Premier League series. First question paper is released today in the morning, so if you have not yet downloaded that question paper and solved it, I request you, before watching this video, go download that question paper, try to solve it in 30 minutes, then you can come back and watch this video. That will be more beneficial for you. Or if you don't get any time, maybe you are busy for various reason, maybe you are doing something else, so in that case at least have that question paper PDF with you. That will help you to understand the solutions, understand the logic behind the solutions. So today we are going to discuss about all the solution of the 30 questions that we have given to you. So don't go anywhere, sit tight, hold through the entire lecture. So we are going to start with first problem, obviously. So let's look into the first problem. A charged dust particle of radius 5 into 10 to the power of minus 7 meter is located in a horizontal electric field having an intensity of 6 pi 10 to the power of 5 volt per meter. The surrounding medium is air with the coefficient of viscosity eta equals to 1.6 times 10 to the power of minus 5 Newton per meter square if the particle moves with a uniform horizontal speed. So this is very important thing, that it is moving with a uniform horizontal speed and the value is 0.2 meter per second. So from now on, I hope that you have the question paper with you. I will not read the question. I will just briefly mark the data, important data, and then we will start to solve the question. Okay. Before, if I read the entire question paper, it will waste my time as well as your time. So I hope that you have already read the question paper and tried to solve it. So what all are given here? The radius is given. First information given is radius. Radius is 5 times 10 to the power of minus 7. Okay, if you have tried to solve this question and you are not able to solve this question, then you must read the question paper first. The electric field intensity, that is electric field itself. Okay, sometime it is called electric field intensity or sometime it is called electric field, both are same. Electric field is given 6 pi. Now if you see here, they have given volt per meter, not usual Newton per coulomb, but that is same, both units are same. I mentioned that also in the past. So 6 pi 10 to the power 5, and eta is given. Everything is given in SI, so I am not using the units here. As long as everything is in a SI system, we don't need to bother about units too much. Okay, if there is some unit, suppose here it was mentioned 2 centimeter per second, then we have to convert it into meter per second, right? But it is not done. So velocity is given 0.02 meter per second. Now this question is not entirely on electric field or electric charges and field chapter. It is based on some of your first PU concept as well. What concept? That is, when an object is moving with the terminal velocity, with the constant velocity in a viscous medium, okay, the force acting on it is given by 6 pi viscous force, 6 pi eta r v, right? We already know that this is the viscous force. Now what all we know, we also know that this force should be balanced by something, so that the terminal velocity, it is moving with a constant velocity. This is the drag force. Okay, this is the drag force that is trying to stop the particle, but the same force should be balanced by electric force, and electric force is Q times E. This is the basic concept. As if it is moving with a constant speed, that means the drag force which is trying to stop it, that is kind of a frictional force, that frictional force should be balanced by the force which is driving it, that is the electric force. That is the major thing, and they have asked you to find the number of electrons, not only Q. So first thing we will do, we will first find the charge Q, then that part, after you find the Q, it is very easy to calculate the E, because it will be very simple value. So if they have given you this complicated question, that means the calculating the number of electron will not be a challenge. Let's see. So 6 pi, if you see the values, the data is given such a way that everything will cancel. See, 6 pi times eta, what is the value of eta? Eta is 1.6 times 10 to the power of minus 5, right? And what is R? R is given 5 times 10 to the power of minus 7, right? And what else? V. V is 0.02. So it will be multiplied. Zero 0.02. Okay, so this is the 6 pi eta RV. Now equals to Q times C. What is Q? Q we don't know. We want to find the charge on that particle, and electric field is given 6 pi times 10 to the power of 5. Right? So everything is given. Now we want to find the value of Q. So what we will do, we will try to write down everything together. So 6 pi cancels. First thing. Next, 1.6, okay, times 5. I'm just writing these values first, okay, times 5 times 0.02 times, okay, 10 to the power of minus 5 minus 7, and once this 10 to the power of 5 comes to this side, it will also become, this was on right hand side, now I am writing this on our left hand side. So what will happen? It will also become minus, right? So I am writing the left hand side first, right, Q, then I am just transferring all the 10 to the powers. Now let's calculate. It will be 1.6 times, so if you see 5 times 0.05, 5 times 0.05 means it will be 0.1, right, times 10 to the power. What is the value of 10 to the power here? 5, 10 minus 10 minus 7 is minus 17. So total is minus 17. Okay. Now we know that the charge of an electron is 10 to the power of minus 19, right? So how can we write it in terms of 10 to the power of minus 19? Only thing what we will do, we will not disturb this term, because this is also involved with the charge, right? So we will be smart, and what we will do, we will multiply with 100 and divided by 100. So dividing by 100 will make this minus 17 as minus 19, right? It will become minus 19, right? So what will happen? 0.1 times 100. 0.1 times 100 means 0.1 times 100 means 1.6. Q equals to 1.6 times 10 to the power of minus 19. We will write first, okay, times 0.1 multiplied by 100, that is 10. Okay, so this is the charge of an electron, and this is the number of the electron, right? We know that Q equals to Ne. E is this and N should be this, right? So the value is 10. So there are 10 electrons present in this case. Now tell me in the comment below how many of you have actually get this answer correct. So I will see how many of you actually got this answer correct. Now let's see. Next question. Gaussian sphere encloses an electric dipole with it. The total flux across the sphere. So Gaussian surface encloses a dipole. Dipole means plus Q and minus Q. So what is the net charge? Net charge should be 0. So net charge 0 means net electric flux will also be 0. Simple question. Okay, as you can expect in KCET, there are some high level questions mixed with some easy questions. So we have to answer the easy questions quickly and move on. Next, a small oil drop of mass 10 to the power of minus 6 kilogram is hanging at rest between two plates separated by 1 millimeter, having a potential difference of 500 volt. The charge on the drop is, so what is the thing? A small oil drop, okay, mass is 10 to the power of minus 6 kilograms, right? Okay, and at rest between plates of separated by the plates are separated by 1 millimeter, and the potential difference is 500 volts. Don't think this is a capacitor problem. This is not a capacitor problem. Okay, so it is hanging like this. That means the mass is acting downward, the mass is acting downward, and what else is acting upward to balance this? Only thing that can balance is the electric field. So electric field balancing means we know that the force is Q times C, right? So that force should be equal. So from this problem we know that Q times E should be equals to mg. Okay, now we have to calculate the Q. Now before calculating Q, we don't know E as well. E is not directly given. What is given? Given is volt is 500 volt, voltage difference basically, and the difference, the distance difference is 1 millimeter, right? So what we can write from here, that electric field is given by delta V by delta X, right? So 500 divided by, what is 1 millimeter? 1 millimeter means 10 to the power of minus 3, right? So it will be 500 times 10 to the power of 3 volt per meter. This is the electric field. So Q will be mg divided by E. What is m here? M here is given 10 to the power of minus 6. G is 10. Okay, and E is, if you write E, it will be 5 times 10 to the power of 5, right? So it will be 5 times 10 to the power of 5, right? Now let's calculate. It will be 2 times this 5 will go up and it will become minus, so minus 6 minus 5 minus 11. So 2 times 10 to the power of minus 11. So correct answer is option B. So they will not always give you direct questions. See, the problem, the formula is very simple. Only thing you need to know is how you can calculate the electric field, right? If you know how to calculate the electric field, then this problem is very simple. As long as there is an electric field, there is a weight, only thing that can balance in this case is electric field. Okay, so be careful and try to answer these questions very quickly. This is not a difficult question. Only thing is how you can apply the concept. Okay, nothing is unknown in this case, right? Two metal spheres of radius 0.1 meter and 0.02 meter are given a charge of 15 microcoulomb and 45 microcoulomb respectively. So initially total charge is 15 plus 45, that is 60 millicoulomb, not microcoulomb, it is millicoulomb, right? And one radius is 0.1 meter and another radius is 0.02 meter. Okay, are given in the charge. They are then connected by a wire. So they have total charge, I already calculated, 60 microcoulomb. One is smaller, another one is slightly bigger. So I have drawn it wrong. So R1 is bigger. 0.1 is obviously bigger than 0.02. Now you have connected them. Now what will happen? Will the charge be divided into equal halves? If you are saying the charge will be divided into equal halves, then you are wrong. Sorry. Charge will not be divided into two equal halves because they are not identical. If you read some of the questions, they generally mention two identical spheres. Okay, two spheres having same radius. In that case, it will be equal. But here, these two spheres are not same. They have different radius. So for different radius, now what will be the case where the charge exchange will stop? Some of them, one of them has 15 millicoulomb, another has 45 millicoulomb. So what will happen? Obviously, they will exchange charges. Now, when the charge will stop? The charge will stop when they have attained same potential. So when both of them has same potential, so if suppose the potential in this case is V, then when this will also attain the same potential V, then this exchange of charge will stop. So now after the exchange of charge is stopped, suppose this is Q1 and this is Q2. So now we can write Q1 plus Q2 is the total charge. Charge cannot be created or destroyed. So total charge should be 60 times 10 to the power of minus 3 coulomb. Okay, so this is the total charge. Now what else? We know that potential in case of a sphere can be written by K charge enclosed in it divided by the radius, right? So charge enclosed by it in the radius. Now we have to find the charge, final charge on the first sphere. That means we have to find Q1. So what we will do, we will find Q2 in terms of Q1. 60 times 10 to the power of minus 3 minus, okay, don't make it confusing. What we will do, we will make Q1 Q2 also in millicoulomb. Okay, so that factor will cancel. If we make Q1 Q2 also in millicoulomb, then the factor will cancel. Okay, so it will, we can write simply by like this. Now what I mean by factor will be cancelled, I will explain that as well. Now what, this is the potential of this sphere, right? We know that KQ by R. Similarly for second sphere it will be KQ2 by R2. K cancels. Now if I take the factor millicoulomb in the charge itself, then what will happen when once we convert it into coulomb, okay, K is cancelled, right? So what will happen is Q2 times 10 to the power of minus 3 divided by R2. So this will cancel. So we don't need to worry about this any more. So instead of that, what we will focus on, we will focus on the exact difference only. Okay. Now we will put the values. Q1 we don't know, R1 is 0.1 and Q2 is 60 minus Q1 divided by R2 is 0.02, right? So we have simplified this equation. Now what we will do, we will simplify it more. So what we will do, we will just exchange the values. So 0.02 divided by 0.1 Q1. So 1 point cancels, so it will shift here. So 0.2 is still there. So to remove this point, what we have to do, we have to multiply with the 10 in the denominator, right? So it will be 2 divided by 10. So it will cancel. 5 equals to 60 minus Q1, right? So Q1 equals to 5 6 300 minus 5 Q1. Okay, now this 5 Q1 will come on this side, it will become positive. So we'll get 6 Q1 equals to 300 or Q1 equals to 50. Okay, so Q1 is 50. So option is option A. So if you have answered this question based on the fact that charges will be equally distributed, then you should know that this is not true for unequal size objects. It is true only for identical objects. If the object is not equal, then they will stop at the same potential. This is a very simple problem, not a difficult one. Only concept that you need to apply is that instead of having same charge, it will be the potential that will be same, and potential for a spherical object on its surface is given by KQ1 by KQ by R. Okay, inside the sphere also, as long as it is a conductor, the potential will be constant inside. So it will be the expression for the potential. Okay, if you have any doubt regarding this, you can mention that in the comment. Two concentric spheres of radii capital R and small r have positive charges Q1 and Q2 with equal surface charge densities. I have solved this question. I think I remember I have solved this question in one of your homework problem, or I have given this as a homework problem, not yet solved. I am not sure, but I think I have solved this. So if you have seen that video, you should be directly able to answer that. This is the correct answer. I will explain it anyway. So two spheres, okay, having same surface charge densities. So two sphere, one of them is radius smaller, a capital R, one of them is smaller. So this is smaller, this is capital R, right? Now this one has a charge Q1, this one has a charge Q2. So, and surface charge density for both the sphere is same, that is sigma. If surface charge density is sigma, then what is the value of Q1? Q1 is the surface area, 4 pi r square times the charge density. And what is the value of Q2? Q2 is 4 pi r square sigma. Same value. Now, what is the potential due to one of the spheres? Say bigger sphere. Potential due to the bigger sphere, VR, is given by 1 by 4 pi epsilon naught. I am not writing K because there is a reason it will cancel. Right? 1 by 4 pi epsilon naught Q1 by R. That is the potential for a sphere. I just discussed in our previous problem. Right? So 1 by 4 pi epsilon naught Q1 is 4 pi R square divided sigma divided by R, right? So 4 pi cancels, one of the R is cancelled. So what is left? Left is sigma R divided by epsilon naught. This is the potential due to one sphere, that is the bigger sphere. Now what is the potential due to smaller sphere? Similarly, we can write VR is equal to sigma R divided by epsilon naught. So what is the total potential? Potential is a scalar quantity, so they will be simply added. So it will be sigma R by epsilon naught plus sigma small r divided by epsilon naught, sigma by epsilon naught common R plus R. So this is the correct answer. Okay. Now let's move on. What is the electric potential at a distance 9 centimeter from 3 nanocoulomb? This is the simplest question I have ever seen, right? So what is the electric potential? Electric potential, we know that V is KQ by R. Okay, simple formula. So what is K? K is 9 times 10 to the power of 9. What is Q? Q is 3 nanocoulomb. Nano means 10 to the power of minus 9. What is the distance? Distance is 9 centimeter, and instead of 9 centimeter, we will write like this, right? As I said, always use 10 to the power of minus 2 in the denominator. Even if you forget, that will save a lot of time, because whatever decimal you are going to use, eventually it will be converted into 10 to the power, right? So now this 9 will cancel. This 10 to the power 9, this 10 to the power 9 will cancel. Now what will be left with? 3 divided by 10 to the power of minus 2, that is 300. This will go up and it will become 10 to the power of 2, that is 100. So correct answer is 300 volts. Okay, simple problem, very simple problem. Only thing is to have to calculate the units correctly, right? This kind of problem is also very common in KCET. A charge of 6.75 microcoulomb, okay, in an electric field is acted upon by a force of 2.5 Newton. The potential gradient at this point is, okay, so if you see potential gradient, a new term, but if you look into the units for the given answer, it is quietly hidden. But if you have solved the first few problems and read them properly, then you know this is nothing but electric field, right? Potential gradient means electric field is basically dV by dx, right? So this is a clever wording about this term. Otherwise, this is nothing but electric field. So they have asked you to find the electric field when the charge is given and force is given, right? So what we know, force is Q times E, 2.5 Newton is given. Q is given 6.75. Sorry, Q is given. Okay, 6.75 microcoulomb. Micro means 10 to the power of minus 6. times E. So E is 2.5 times 10 to the power of 6 divided by 6.7. Right? I have taken this directly. Instead of wasting a step, I directly used it. I have directly taken it on the side and make it positive and then just divided by this term. Right? Now, if you see all the terms, if you calculate this, okay, you will get some version of this, some decimal version of it, right? All the options have same value. So you don't need to calculate anything else. You just need to check which one is the closest 10 to the power values. You don't need to do the calculation after this. If you see, only closest value is 10 to the power of 5, because here we had 10 to the power of 6. Now why 10 to the power of 5 it will happen? Because it is 2.5 and denominator is 6.75. So it is greater than 1 and greater than the numerator except 10 to the power. So what we can do, we have to take one, borrow 110 from here. So it will be 25 divided by 6.75 times 10 to the power of 5. Now this value is nothing but 3.71, because for all the options given there is no other option, and also this is the closest 10 to the power given. So by closing our eyes we can simply mark this as our answer. Okay. Now mention that in the comment below. Have you got this question correctly? If yes, mention that I have corrected this problem. Okay, this is a very simple yet just a wording problem. Okay, so this is also a type of clever. Now, potential energy of a proton and an electron in hydrogen atom separated by a distance of 0.5 angstrom is. This is not related to a nucleus and everything. It is just simply electrostatic problem. They have asked you to find the potential energy of proton and an electron. We know that potential energy is given by K Q1 Q2 by R. Okay, most of the questions are coming from potential, right? No, there are some questions for electric field as well. Now they have asked you to calculate the potential energy, right? K is 9 times 10 to the power of 9. Q1, Q2 both are same. Only thing is one is positive, another one is negative. So basically one will be 1.6 times 10 to the power of minus 19, that is proton, and another one will be positive, right? One is positive, one is negative. So it will be, so instead of going into all this, what I am saying that if Q1 is E, then Q2 will be minus E, right? So instead of writing everything, I will just simply take this value here minus, and I will simply use the value 10 to the power of 9, 1.6 times 1.6 times 10 to the power of minus 38. Why minus 38? Tell me, mention that in the comment if you have understood why I have written this. Okay. So let me explain. Don't worry, don't write in the comment. E is 1.6 into 10 to the power of minus 19, right? That is 1 E. Here there will be another E multiplied, right? So one other E multiplied means 1.6 times 10 to the power of another minus 19. So what will happen? 1.6 times 1.6 times 10 to the power of minus 19 minus 19 minus 38. So I have just simply directly written it because there is a space issue. So 0.5 angstrom is 0.5 times 10 to the power of minus 10. Angstrom means 10 to the power of minus 10 meter, right? Now 0.5 it will go up and it will become 2. So we will write this like minus 9 times 1.6 times 1.6. So basically 16 square, and then you have to add 1 decimal, second decimal, right? So 16 square is 256. So after that you have to take 2 decimals, so 2.56 times this 0.5 will go up and it will become 2 times 10 to the power of minus 38 plus 9. This minus 10 will go up and it will also become plus, it will become minus 19. Okay, clear? 10 to the power of minus 19, right? Now here you cannot do anything else because all the options, all the calculations, everything is given. They are not everything, they have 10 to the power minus 19. So your smart brain, you have to be a little bit more smarter than this, right? So what we will do, we will again do some Salpa approximation. What approximation we will do? We will assume this 9 as 10. Okay, easy. And then we will complete the multiplication. 2.56 times 2, right? So it will be minus 25.6 times 2, 10 to the power minus 19 is obviously there. Okay. So 25.6 times 2 is 50 point something. So it will be approximately 50. Even though it is not 50, it is our approximated value, right? Because we have assumed this 9 to be 10. So whatever we have calculated, it will be slightly less than that. So only given option is option D, where it is very close to 50, as well as 10 to the power minus 19. Both of our criteria is fulfilling for this. You can try and calculate this using your calculator, though it is not allowed in your exam, but to verify if the calculation is correct or not, later on you can do this. Now I request, while writing these question papers, for your own benefit, don't use calculators. Don't use calculators, it is for your own benefit. Now let's move on to the next problem. Two free protons are separated by a distance of 2 angstrom. If one proton is kept stationary and the other proton is released, the kinetic energy of the second proton when it is at infinite distance from the separation is. Now this is exactly same problem as previous problem. If you understood the previous problem, you should be able to answer this question. Only thing is that you have to understood that when they are separated by a distance of 2 angstrom, okay, they have some potential energy, and this is kept and this is allowed to move till infinity, right? So when it goes to infinity, its potential energy becomes 0. The potential energy of the system becomes 0. So potential energy of the system becomes 0 means what is the difference in potential energy? Difference in potential energy will be U minus 0. So delta U will be U minus 0, that is U. So the entire energy will be converted into kinetic energy, right? So this is actually the kinetic energy. Okay, so kinetic energy is nothing but the potential energy of the system at the beginning. Okay, because final potential energy is 0, right? So same equation, potential energy is K Q1 Q2 by R. Okay, only thing here is they are both positive, so we don't need to worry about too much. So we already have used some calculation logic, so I am not going to explain why it is 2.56, why it is 10 to the power minus 38. I am not going to explain that. If you are watching from the middle, I request you go back and check the previous problem where I have explained why this is like this, and R is 2 angstrom. So it will be, now again we will do the same approximation. Okay, we will assume this 9 is as 10 and 2.56, 25.6 times 10 to the power of minus 19 divided by 2. Okay, if you cancel this, you will get 12.5, and if you multiply it with 10, sorry, not, I made a mistake. If you have already multiplied the 10, so your correct answer will be around 12.5, less than 12.5 times 10 to the power of minus 19. So less than 12 and 10 to the power of minus 19, only option is 11, that is slightly less than 12 and 10 to the power minus 19. So this is the correct option. Okay, not the 9, because if there was 9, because 9 is getting multiplied, right, with 1.25, so it will not be 9. Okay, you cannot approximate that to be 9. It will be grow more than 9 but less than 12.5. So the correct answer is 11.5. Now at the center of the square ABCD, there is situated an electric charge of 100 nanocoulomb. Find the work done in moving the charge from 10 10 nanocoulomb from corner of A to corner of B if the square where the side square is 2 centimeters. So, it's a very simple problem. There is a square is here. This is a conceptual problem. This no mathematics is required. Okay. So you have kept 100 nanocoulomb here. Okay, and you are moving a charge from here to here. Okay, a 10 nanocoulomb charge. Now, if you see, both the charges are equidistant, right? If this distance is r, this will be also r because it is the center. At the center, we know that, and this is also a square. For a center, we know that all the vertices are at same distance, right? So, whatever distance from this point to this point will be the same distance from this point to this point. So, the potential at this point, say VA, and if the potential at this point is VB, potential, both the potentials will be same because potential is a scalar quantity and it only depends on the K Q by R. So, K is constant, Q is given here, and R is constant here as we see. So, VA equals to VB, right? So, we are moving from a point from a potential to a same potential. That means potential difference between final and initial point is 0. So, if the potential difference is 0, we can write the work done is 0. So, the correct answer is 0. Simple, right? No rocket science. Okay, let's continue to the next problem. Work done in carrying an electron from a point A to point B in an electric field is 3.2 times 10 to the power of minus 18 joule. The potential difference VB minus VA is. So, this is the same problem. Potential energy is given here and they have asked you to find the potential difference. So, energy difference is potential difference. Sorry. Sometimes I write V and U same. Okay. So, V times Q, right? This is the formula. If you remember QV is the work done, right? So, that is the energy stored. So, they have given you the work done. Okay, given you the potential energy. Work done is same as potential energy. 3.2 times 10 to the power of minus 18. And they have asked you to find the potential difference, that is delta V. Okay, and electron, it is given an electron. So, 1.6 times 10 to the power of minus 19, right? So, delta V is equals to 3.2 times 10 to the power of minus 18 divided by 1.6 times 10 to the power of minus 19, cancels 2. Okay, so it will be 2 times 10 to the power of 1, so 20 volts. So the correct answer is option D. Okay. A molecule with a dipole moment P is placed in an electric field of strength E. Initially, the dipole is aligned parallel to the electric field and the dipole is to be anti-parallel to the field, the work done required. Okay. So, we know that work done in this case is given by P cos theta 0 minus cos theta final. Okay, if you remember, I have already reduced and derived this equation in the lecture where I have taught about the potential energy of an dipole in an electric field. So, if you have missed that, go back and check that lecture. Okay, now P is given. Oh, P is given as P only. E is also given as E only. Cos theta, initially it was parallel, right? So, electric field is in this direction. P is also in this direction. So, the angle is 0. So, cos 0 means 1. Now, once it becomes anti-parallel, so now electric field is in this direction. Okay, this is the initial position. Now, the dipole is in this direction. Final. Okay, this is the final. Now, so what will happen is, so the angle will now be this, that is 180 degree, right? So, 180 cos 180 is minus 1, right? So, PE 1 plus 1, that is 2P. Okay, so 2P is the answer. This is a very common problem. Okay, this is a very common problem even for your PU board MCQ. This type of question comes. Okay, sometimes they will ask you if the angle is rotated by 90 degree, what is the work done, right? So, you have to remember that. Now, let's move on to the next problem. two point charges plus 2 coulomb and plus 6 coulomb repel each other with a force of 12 Newton. If a charge of minus 2 coulomb is given to each of these charges, what will be the force now? So, two charges was here, okay, plus 2 coulomb, another one was plus 6 coulomb, okay. Now, what you have done, you have added minus 2 coulomb to each of them, right? Now, what is the charge here? Net charge here is 0, net charge here is 4, okay. So, what is the mutual force now? This is now neutral object. So, neutral object does not apply any electric force to another charge. So, the force will be 0, okay. Remember that. Next, two point charges are 3 meter apart and their sum is 8 microcoulomb. If the force of repulsion between them is 0.12 Newton, charges are, okay, 2 point. This is a very simple problem. 2 point charges, say I am not using Q1, Q2, it will be difficult to manage later on. So let me use them X and Y, okay. So one charge is X, another charge is Y. So that is given as 8 microcoulomb, okay. One charge is 8 microcoulomb, another is y microcoulomb. So x microcoulomb, y microcoulomb, if you add them, we will get 8 microcoulomb, okay. Now what is given is the force of repulsion between them is given, okay. Both of them are in microcoulomb, remember this. Force of repulsion is given. Force of repulsion means F equals to K Q1 Q2 by R square. Now, K is 9 times 10 to the power of 9 times x times 10 to the power of minus 6 times y times 10 to the power of minus 6 divided by r square. R square is 3 meter, distance is 3. So, 3 square, and this force is given 0.012. Okay. So, this is given. Simple problem, right? Now, what we have to do, this 3 square will become what? 3 square will become 9. Let's not waste a line here. So, this will cancel, and what we will get, 0.12 is equals to minus 12 plus 9, that is 10 to the power of minus 3, right? 10 to the power of minus 3. Now, if I take this 10 to the power of minus 3 to this side, what will happen? It will become 10 to the power of plus 3. So, 10 to the power of plus 3 means 1000 multiply 0.12 is 1000. So, it will become only 12. All the points will be gone. All the points will be gone and it will become only 12. This is a shortcut I am doing. If you have any doubts, this is a very simple shortcut. Now, x times y. X we know, x, and we are trying to find x and y both. So, x is equals to 8 minus, y is equals to 8 minus x, right? So, we will put that value here, x times y. So, x times y is 8 minus x, okay. So, 12 is equals to 8x minus x square. Now, take everything on this side, x square minus 8x plus 12 equals to 0, or x square minus 12x x square minus 6x minus 2x plus 12 is equal to 0, or x minus 6 minus 2 x minus 6 to 0, or x minus 6 times x minus 2 equals to 0. So either x equals to 6 or x equals to 2. Now if x equals to 6, then y is equals to 2, and if x equals to 2, then y will be equals to 6. So the correct answer is 6 microcoulomb and 2 microcoulomb. Okay, any of the pair. Okay, see, if one charge is 6, the other will be 2. If one is 2, then other will be 6. Right? Simple method for this. Now, two charges two charges 4q and q are 3x apart in air. Okay, so 4q and two charges, one is 4q, another one is q, and they are separated by a distance 3x. In air. Okay, a charge capital Q is placed at a point on the line joining. Suppose we have placed a capital Q somewhere here. Okay, so that the system of these three charges remain equilibrium. Then the distance of Q from 4Q and the value of Q. Now these two charges were positive. Okay, now what do you think will be the sign of this capital Q so that the system is in equilibrium? So only one way to make this system in equilibrium if this capital Q is negative. Now what will happen if this capital Q is negative? So this 4Q charge, let us consider from the point of view of Q first. Okay, we have to use at least two point of views here to solve it. First point of view will give us the location, second point of view will give us the uh, charge. Now what I am saying about point of view? Point of view means equilibrium of each of these three charges. Okay, we can consider equilibrium of all these three charges. That means we have 3 point of views, but we need at least 2, minimum 2, maximum also 2. 2 is sufficient. Now first let us consider the point Q. From the point Q, what is the force acting on this point Q? So this point Q is getting attracted towards this 4Q in this direction, and also it is getting attracted towards this Q in this direction. Now if the system is in equilibrium, what is the rule? That these two forces should be equal, right? Both are already opposite and they should be equal. Now we know that Q is negative. We will use that later part. Okay, right now what we are interested in the force. So K times 4Q, and this distance was 3x. Suppose this distance is y. Assume this distance is y. Okay, so this distance will be 3x minus y. Right? Any doubt? Let me redraw this diagram so that you are clear. Okay. 4Q here, Q here. The capital Q charge should be close to the small q charge. Okay. Now I am saying this distance is y. This distance will be 3x minus y, and the total distance is 3x. Okay. Now what we have to do? We have to apply Coulomb's law for this charge Q first. So whatever the force acting on this charge from both sides, that should be equal. So K 4Q capital Q divided by y square equals to K small q capital Q divided by 3x minus y whole square. Okay, so this will cancel, k cancel, q capital Q small q capital Q cancel. So what we get? We get 4 by y square equals to 1 by 3x minus y whole square. Now what we will do? We will take this x and y term on our left hand side and the constant term on our right hand side. So we will write this as 3x minus y divided by y whole square equals to 1 by 4. Can I write it like this or not? I can write this, right? If I take this thing on this side, so it will be whole square of 3x minus y divided by y, right? Now this is, what is this? This is 1 by 2 whole square. So we can cancel this whole square and we can write 3x minus y by y equals to half. Now mathematically there is a possibility of plus and minus. I am using plus 1. You can try and check what will be the case if you are using negative 1. Okay. So 6x minus 2y equals to y. Okay, so let me take this side. So 6x equals to 3y. So y equals to 2x. So y we have calculated 2x. Right? Now what we have to calculate? We have to calculate now the value of q. So why we have calculated? We have to calculate the value of q. So what we will do? Now we will use our second point of view. You can use any one of the point of view left. That is, either you can use 4q or you can use small q. Let me use the small q one, that appears to be simple. Okay. So what is the force on this charge? There are two forces acting on this charge. One is the repulsion force of this charge, okay, repelling it in this direction, and there is an attraction force due to capital Q which is attracting in this direction. Now the entire system is in equilibrium, so all the charges are in equilibrium. So all the forces on each of these charges must be balanced. Now what is the force on this? 4q times q divided by, now the distance in this case is total distance 3x square, that is the repulsion force. Now what is the attraction force? Now here you have to remember that this force, to get exact answer whether it is plus or minus, you have to use this symbol. Okay, you have to use this symbol to get the sign as well. K Q, capital Q divided by 3x minus 2x equals to 0. Okay, in this, if you use this way, then you, both of them you will get a sign, right? So now let me write on the other side. So K small q capital Q divided by 3x minus 2x whole square, that is x square, equals to K 4q square divided by 3x whole square, that is 9x square, right? So 9x square. So x square cancels. This one of the q will cancel, k cancel. Okay, so capital Q is nothing but minus 4q. So the capital Q is minus 4 by 9q. Okay, 4 by 9q. There is a 9 here, right? So this 9 is coming from the square of this term, right? So 4 by 9q, but minus. So the correct answer is this 2x comma minus 4q by 9. Okay. Now this is a little tricky question. Now mention that how many of you have got this answer correct. 2x calculating 2x is easy, but calculating the capital Q is little bit tricky. You have to use 2 points. And even though this is a little longer question, remember that not all the questions are longer, right? So we have solved some questions quickly as well. Now a charge Q is placed at each opposite corners of a square. A charge small q is placed at each two other corners. If the net electrical force on capital Q is 0, then capital Q by small q. This is also a little tricky question, but if you draw the diagram, it will be simplified for you. So what is this? So two charges, one charge is placed here, suppose another charge is placed here. Now next charge is placed here, next charge is placed. Now what is said that net electrical force on this charge is 0. Any one of the Q you can take, net electrical force on capital Q is 0. Okay. Now what they have asked you to find the ratio of capital Q by small q. Now what are the forces acting on this charge? Let me consider this charge. So first of all, there is a repulsion force here. This charge is getting repelled in this direction, right? And what else? This charge now this capital Q, these small q's must be negative. If capital Q's are positive, then small q must be negative, because this is the repulsion force. So this is acting in this direction. So to balance this, it has to, the attractive force has to act in this direction. Okay, attractive force must act in this direction. Okay, now the resultant of these two forces will be in this direction, so it will balance it, right? Now what is this force? What is this distance? First tell me what is this distance. If the side is A, suppose side is A, then what is the distance between these two corners? Distance will be A root 2. We know that already. Okay, we have solved similar problem during our lecture, where we have already know that the distance is basically A root 2, right? Now if this is A, then this is A root 2. Now this is A root 2 means what is the force? So first find this force. This force will be, that is FQQ. This is given by K Q square by A root 2 whole square. Both of them are Q, right? So Q square, K Q square by A square 2 or 2A square. Okay, let me simplify this. 2A square. Don't get confused. So 2A square. Now we have to calculate these two forces. What is this force? This force is any one force. First write this force. Okay, F, capital Q, small q. The same amount of force will be here also. Okay, because magnitude of the charges are same, and the distance is also same for both cases. So it will be K small q capital Q divided by A square. Right, in this case distance is only A, this is also A, this is also A, right? Now this is okay. Now how can we find the resultant of these two forces? Okay, to find the resultant of these two forces, we have to take the component of these two forces in this direction. Okay, so if this is the force FQQ, this is also FQQ, both are same. Okay, if we find the component, this angle is 45 degrees, this is also 45 degrees, right? So if we take the component of these two forces along this axis, then the total force will be twice, right? Twice of this component. One component, let me take one component first. One component is, say one component is K small q capital Q divided by A square times cos 45. Cos 45 means 1 by root 2. Okay, so this is cos component, right? This is cos component. Cos component, it will be 1 by root 2, right? Similarly, another one, for this is for, suppose this, for this one, there will be another force, again it will be cos component, this is the adjacent angle. So it will be total force will be twice of that, times 2, right? This is the total force. Now these two forces should be equal. Only then this charge will be in equilibrium, right? So we have to compare these two forces. So K capital Q square by 2A square. Now while solving this problem on your notebook, while you are in a hurry, what you can do, you can check what all are common and you can remove them directly. For example, you don't need to write K, continue writing K's, because that will be automatically cancel. And also Here a square is common, it will cancel, right? Q, one of the Q is common, it will cancel. What they have asked you to find? Capital Q by small q. So what we will do? Capital Q by small q, this 2 will go up, 2 times 2 divided by root 2. So it is 4 by root 2. Or what is 4 by root 2? What is 4 by root 2? 4 by root 2 is 2 root 2. See, none of the answer is given here. This is a bonus question. Okay. Or I think it should be have been given as plus 2 root 2. No. Sorry. It is minus 2 root 2, right? Because as I said, one of the charges has to be negative. Sorry, my mistake. So one of the charges has to be negative. So the ratio will be negative, right? Because only then it will create an equilibrium. So minus 2 root 2. The correct answer is option A. Okay. Whatever you comment you have regarding this problem, if you have any doubts, you can mention that in the comment below, we can discuss. Now, if the charge on a body is plus 1 nanocoulomb, then how many electrons are removed from the body? Now, this is a very common problem. This is given in your book as well. Okay, you should be able to solve this in a glance, but let me solve it. We know that Q is equals to Ne, and it is 1 nanocoulomb. 1 nanocoulomb means 10 to the power of minus 9. N we are trying to find. E is 1.6 times 10 to the power of minus 19. So N is basically 10 to the power of minus 9. 10 to the power of minus 9 divided by 1.6 times 10 to the power of minus 19. So if you cancel this, 10 to the power of 10 divided by 1.6. So it will be 6.25. See, I don't know the answer, exact calculation, but I know it will be this. Why? Because all the options are 6.25, right? So 1 by 1.6 must be 6.25, but I know 10 to the power of 10 was here. So I have to take 1 10 out, and rest of the 9 10s will be still there. So the correct answer is this. Even after reaching up to this point, you can check which one is the closest 10 to the powers. Okay. So closest 10 to the powers is 10 to the power of 9. That is the closest to 10 to the power 10. So that will be the answer. Two small spheres each having the charge plus q. So last one was a very easy question, right? So even if there are some longer questions, there are some easy questions to compensate. Two small spheres each having the charge plus q are suspended by insulating threads of length L from a hook. This arrangement is taken in space where there is no gravitational effect. The angle between the two suspension and the tension of the each wire will be. This is also very simple question. So what will happen when you take two charges hang by say L and L, instead of making this shape, both of them has L length, right? So when they are kept in gravity, there is a component of gravity that will be balanced by the tension, right? We know this. This is a very common problem for us in mechanics. Okay, so tension will balance the gravity. Okay, and there will be a force of repulsion between these two. Okay, so that will be balanced as well by the inner component. So everything will be balanced. But once this is in space, these bottom components are no longer there. Okay, so bottom components are no longer there. So whatever tension it is, don't have to balance these downward components. So only force that will be there is this repulsion forces. Okay, so only way to balance these repulsion forces is that only way to balance these repulsion forces, that they will be making an angle 180 degree. Okay, this is a very conceptual question. There is no other forces involved. So once you have hang them, they will get flattened and they will make an angle 180 degree. So the total distance now in this case will be L plus L, that is 2L. Okay, so total distance will be 2L. Charge is given by Q and Q. So what is the force? Force will be very simple. 1 by 4 pi epsilon. Why I am writing 1 by 4 pi epsilon? Because look into the options, they have given 1 by 4 pi epsilon naught, but that is the formal name, right? So whenever you are writing your name in your answer sheet or exam paper, you are writing your formal name. But when you are talking to your friends, they can call you by your nickname. So K or Coulomb constant is the nickname, but this is the formal name. So whenever the answer is involved using this, we have to use this. So 2L whole square, right? The total distance is 2L. So the correct answer is option A. Simple. Okay. I know many of you may have answered this, but maybe you have answered this as L square. It is not L square, but it will be 2L whole square. Now, to charge sphere separated by a distance d, exert a force or F on each other. If they are immersed in the liquid of dielectric constant 2, then what is the force? So what is the meaning of that? So they have, we have two charges, the force between them is F. Now the entire system is immersed in a dielectric medium of constant K. Now what is the force between these two charges? Right? Now we remember that Coulomb force in its formal form comes like this. Right? Now everything about this term is not changing. This is constant. The only thing that is changing, this epsilon naught. Epsilon naught is only when there is space, that is vacuum. But when it is inside a dielectric medium, then this can be written as capital K. Capital K is the dielectric constant times epsilon naught. Okay. Now dielectric constant is given by 2. You have to remember this. If you want the derivation for this, I can do the derivation sometime later. Otherwise, this is a very simple derivation. So the force, for initially the force is given like this. Now this will be F divided by K, that is F by 2. So correct option is option A. Two highly polished charged copper spheres have radii in the ratio 1:2. The sum of the charges in them is 75 microcoulomb. The electrostatic force between them when they are brought in contact and then placed 3 meters apart. So this is a very similar problem to that what we have solved in the few problems back, where we said, so one of them is 1 diameter, say 1 unit. Another one will be then 2 unit, right? So diameter is given, and we know that they will exchange the charges till they are at same potential. Excuse me. So they will be at the same potential. So potential of this charge is this sphere is K. Say the charge on this sphere is Q1. So Q1 divided by 1. Okay. And potential of this will be same value K Q2 by 2, right? Now we can compare these two values. K will cancel, obviously they are same. So Q1 by 1, Q2 is 75 minus Q1 by 2, right? So total charge is 75, so it will be minus of the other charge. So we can write 2Q1 is equal to 75 minus Q1, or 3Q1 equals to 75, or Q1 equals to 25. Okay. So Q1 we have calculated. Now what we have to do? We have to calculate Q2. So Q2 is given by 75 minus 25, that is 50. Everything is microcoulomb. Both of them are micro. Okay. Now what we have to do? You have to calculate the force. So force is 1 by 4 pi epsilon naught, or K Q1 Q2 by R square, 9 times 10 to the power of 9 times Q1. Q1 is 25. Q2 is 50 divided by R square. R is 3. 3 square, that means 9. 9 cancels. Okay. 525s are and microcoulomb. Sorry, both of them are microcoulomb. So 10 to the power minus 6 minus 6. So it will become 10 to the power of minus 12. Okay. Okay. Now 5 times 10 to the 20, 25 times 5. What is the value? 125. There was an extra 0 here also. 10 to the power of 9 minus 12, that is 10 to the power of minus 3. Minus 3 means what? 10 to the power of minus 3 means we can write this as 1250 minus 3. So 1, 2, 3, 3 decimals. Right? This is the way. So it will be 1.25 newtons. Right? This is the answer. A cube of side 2 centimeter has a charge of 12 microcoulomb. Then the surface charge density is. So a cube total charge on the cube is 12 microcoulomb. Right? And the side has 2 centimeter. Now what is the area then? If the side is 2 centimeter, what is the area? We know that for a cube, how many surfaces are there? There are 6 surfaces, right? So each of them has surface area whole square, right? That is the A square. That is the area of one surface. Now how many surfaces are there? 6, right? This is the total surface area. So we know that the surface charge density is basically charge divided by the total surface area. The charge is given as 12 microcoulomb into the power of minus 6 and divided by 6 times 2 times 10 to the power of minus 2 whole square. Okay. So we can write this as, this will be 2 times 10 to the power of minus 6 divided by 4 times 10 to the power of minus 4. So it will be half. Okay. Half 10 to the power of minus 2. Right? Half 10 to the power of minus 2. Now, none of the answer is matching. Is it? Is it? What I will do, I will borrow a 10 and I will make this minus 3. Right? So, we can write this as 5 times 10 to the power of minus 3. The correct option is this. Even though you have done the calculation correctly, at the end you might think, okay, my answer is not matching with any of the options. So what I will do? You have to think a little bit more and find a solution, because half means 0.5. 0.5 means it will be 10 to the power of minus 3. That way also is it possible, or what you can do, you can take 110 out and you can do that. Okay. Next problem. The force between the electron in the first Bohr orbit and the nucleus in the hydrogen atom is F. If the electron jumps to the third orbit, the force between the electron and the nucleus will be. Now for that question, there is only one thing that you need to answer. This is a very good question. Okay, only one thing you need to remember, that Rn is basically n square R0. R0 is the Bohr or radius, or the radius at the first orbit, right? So now for first orbit, it is there, the force is F, right? So in this case, first orbit, the force was K, whatever Q1, Q2, okay, both of them are E, but I am saying Q1, Q2 divided by R0 square, right? This is the first case. Now second case, it will be R3, third orbit. Third orbit means 3 square R0. So it will be 9 R0. Okay. Now, what will be the value in this case? Now, F dash is K Q1 Q2 divided by 9 R0 whole square. So it will be K Q1 Q2 by 81 R0 square. So 81 R0 means it is F divided by 81, right? So the correct answer is option D. The only thing that you need to know about this question, if you feel this question is hard, I don't blame you. But if you know and solve this question, please mention that in the comment that I have solved that orbit question correctly. Okay. When electric charge is given to an odd shaped conductor, the surface charge density will be, now this is a concept based question. when charge is given to a conductor, charge density is more at the sharp edge. Okay, charge density is more at sharp edge. That is why we use sharp edge for electric charge. Okay, lightning disturber. Okay, lightning rod. Maximum at the plane surface, maximum at the pointed ends. Okay, zero at the pointed ends, uniform all points. Okay, 3-point charges are placed at the corners of an equilateral triangle, assuming only electrostatic force are acting. The system will be in equilibrium. Now, 3-point charges, okay, placed in the corner of an equilateral triangle will not be possible to achieve equilibrium in any of the case. Okay, the system can never be in equilibrium. This is a special case. 3-point charges located at the 3 points, no matter what is the magnitude, what is their sign, they will never be able to achieve equilibrium. Maybe one charge can be at equilibrium, but the entire system will never be at equilibrium. If they are in linear position, okay, then there is a possibility that it is in equilibrium. But if they are not in linear position, they will never be at equilibrium. Now, 2-point charges, 0.1 microcoulomb each are placed at separation of 0.2 meter in air. The electric field strength at the point midway between the charges. This is very simple question. So 2-point charges both are equal magnitude. Okay, place separation of 2 meter in air. So electric field strength at the middle will be 0. Okay, 2-point charges same magnitude. So in this case, electric field due to this will be in this direction. Electric field this in this direction. So they will cancel each other, right? A point charge of plus 4 microcoulomb and another point charge B of minus 1 microcoulomb are placed in air at a distance 1 meter apart. Then the distance of the point on the line joining the charges and from the charge B where the resultant electric field is 0. So what they have said, they have given two charges. Okay, one is A plus 4 microcoulomb, another is B minus 1 microcoulomb, and they have asked you to find the null point or where the electric field is 0. Now remember that if we are trying to find any null point in between the point, in between it is not possible, because the electric field, suppose due to this A is in this direction away from, right, and electric field due to B will also be towards this point. So both will add up. Okay, but if you consider the electric field somewhere here, the electric field will be in this direction and electric field will be in this direction for this charge, right? Now they will cancel each other. So any point near B means we have to consider a point here, somewhere here, where the electric field is 0. Okay, now assume this distance is x. Okay, assume this distance is x. Now what is the total distance from this point? Total distance will be 1 plus x, right? Because this is 1 meter, this distance is 1 meter given already. Nice, total distance is 1 meter. Now let me apply the law of electric field. So what is the electric field due to this charge? Electric field to this charge is kq by r square, 1 plus x whole square, minus this is plus, this electric field is plus, this electric field is minus because the charge is negative. So kq, that is k1 divided by x square. Okay, we have to calculate the x, and there is no net electric field. So net electric field, there is no net electric field means it is 0. So k will cancel. So we can write this as 4 by 1 plus x whole square equals to 1 by x square. Okay, now we will take this on this side. We will write this 4 equals to 1 plus x divided by x whole square. Now we have already used this technique once. Let's see if this technique will work or not. So 2 equals to 1 by x plus 1, right? We just multiplied it inside. So 1 by x is equals to 2 minus 1, that is 1. So x is equals to 1 meter. So we found one answer. Simple. If you use minus 2, the distance will be minus, which is not possible. Basically, that will denote some point on the other side, right? So this is for -1, that is near point B. The answer is 1 meter. 1 meter from this side. Okay. Now, the angle between the dipole moment and electric field at any point on the equatorial plane is. Okay, so angle between dipole moment and electric field. So dipole moment, what is the, suppose this is plus, this is minus. Okay, so dipole moment is from negative to positive, whereas electric field will be in this direction. If you remember, electric field is in the from positive to negative. So that's why we in the final expression we get a negative sign. So negative sign means the angle is basically 180 degree. Okay, the electric field is from negative to positive. Sorry, electric field is from positive to negative, dipole moment is from negative to positive. A charge q situated in a certain distance from a short electric dipole in the end position experiences a force F. If the distance of the charge from the dipole is doubled, the force acting on the charge will be. Very simple question. We know that electric field due to a dipole proportional to 1 by r cube. Okay, so the force experienced by the charge, that should be proportional to q times E. That is, force is also proportional to 1 by r cube. Okay, so distance is doubled, that means new distance. So this was, suppose F1 is 1 by r cube, some constant. This is not Coulomb's constant, some constant. And F2 will be the same constant divided by 2r whole cube. Okay, that is 1 by 8 times k by r cube. That is F1 by 8. So it will be F by 8. So the correct answer is F by 8. Don't write F by 4. Okay, you have to be careful. F by 4 option is not given. Okay, so it will be F by 8. Charges 4q and q are kept separately by a certain distance and are placed at A and B respectively. The electric field at B is E. The electric field at A is. Very, very interesting question. Very, very conceptual question. If you understand this concept, you can answer this easily. From third law of motion, we know that whatever force is acting on this, the same force is acting on this, but in the opposite direction. Okay, maybe it is in this direction, it is in this direction, but same magnitude of force and but in opposite direction. Now this is A, suppose this is B. Okay, now it says that electric field, one charge is 4q, this charge is capital Q. Okay, now if force acting on this is plus F, suppose, then force acting on this is minus F, right? Force acting on this minus F. Now we know that force is nothing but Q times electric field. So electric field is given E. Okay, so force is Q times E. We don't need to worry about it. So force is Q times E. Same force, magnitude wise same force, but direction opposite is acting on the charge A. So this is FB. FA is minus FB. Right, now we know that FA is 4Q times EA equals to minus Q times E. Q cancels, so EA is minus E by 4. So correct answer is minus E by 4. Simple question that you have to remember that charge, the force acting on them are equal and opposite in magnitude, but the electric force is charge times electric field. Okay, so same concepts we have applied, and from that we have able to solve this question. Now the electric field at a point is always continuous. Continuous if there is no charge at that point. Discontinuous only if there is a negative charge. Discontinuous only if there is a positive charge. From the option, it is a 50-50 question. You can from if you are used to KBC. Okay, there is an option called 50-50. So 50% options are deleted. So these two options are directly wrong because there is nothing related to negative and positive. So only A and B are the possible correct answer. Now it is not always continuous. If you remember the properties of electric field lines, it is continuous when there is no charge present. So basically this is the correct answer. If there is no charge present at that point, then it will be continuous at that point. So we have completed all the 30 questions in your first mock test. And if you tell me how much you have scored, you have self-evaluated your answer paper, and tell me how much you have scored. Mention that in the comment below, and tell me also how you like the question paper. If you want Salpa easy question paper or little bit more difficult question paper, that also you mention in the comment. So we will see you in the next video tomorrow, and till then, tata, goodbye, and thank you.